It's a very diverse group of participants, and I'm happy to see that it's coming from many different countries. One of the most frequently asked questions, how and when to capture the Milky Way. Some photographers are interested to capture this typical view of the Milky Way arch rising over the east, which is best visible in between February to June. If you start in February, you need to wake up early morning, around 4 or 5 in the morning, and you will see this Milky Way arch rising. Stars are rising about 4 minutes earlier each night. Due to the Earth rotation around the sun, each star is rising 4 minutes earlier every night. That means in about 1 month, the Milky Way is rising 2 hours earlier, 120 minutes or 2 hours earlier for the same position in the sky. So it's very easy to calculate that if we go from February to June, in June, you will see the same view in early evening. That's why June and July, it's so-called the Milky Way season. However, most photographers don't realize that the Milky Way, the galactic bulge, the brightest part of the Milky Way, could be visible in late winter as well. It is visible in the spring as well. You just need to have to wait a bit more until the galaxy is rising. This view is captured from California. I do an annual workshop there with my colleague Mike Shaw every year, either in June or August during the Perseid meteor shower. And one of our locations is just on the foots of Sierra Nevada in a place known as Alabama Hills. Another place is Bishop, and this year it's going to be also in late June and around the Mammoth Lakes area, one of the two workshops I'm doing in the US this year. Speaking of the techniques, it's a typical golden numbers of night escape photography. 20 seconds, f2.8, and ISO 6400. It's a panorama made from 6 vertical shots and combined together. The super wide angle lens at 14 millimeter. The moon is right behind me. So if you like to use the moonlight on the foreground, you have to plan ahead of time to see when your subject is on the opposite direction compared to the moon. That's when the sky above the landscape will be still dark, especially in high altitude areas where the air transparency is better, and the moon is illuminating the foreground perfectly without vanishing the sky above the foreground. So they need to be as far as possible. So that means the moon needs to be near the horizon, either rising or setting. On this occasion, the moon was setting. This is a first quarter moon, which sets right after midnight. And that's the amount of light you get from this moon phase of about 50%. It's a perfect illumination. If the moon is a phase of 70%, gibbous, or 80%, or full moon, there is no chance for the Milky Way. If the moon is less illuminated, for example, a crescent moon of only 20%, there is no chance to reveal the foreground to this extent. Doing this type of night escape photography is based on planning, which I will talk about it too. The Milky Way is no longer in August, September, and October, is no longer like an arch. That has passed. Now you will see it over the southern horizon in August, the perfect time to see the Milky Way. And in September and October is gradually shifting towards the west, southwest, and it's becoming like a beautiful column over like a river almost over the western horizon. Both of these images are captured in Yellowstone National Park, a latitude of around 45 degrees. And that's where you can see the galactic bulge right above the horizon, but not much higher. This is still continue to be one of the most exciting and interesting time of the year to capture the beauties of the night sky. Especially in September and October in Northern Hemisphere in generally, we have more transparency. And it's a very nice bridge between the summer sky and the winter sky. If you shoot the whole night, you will see all these transitions. At the beginning of the night, you have the summer triangle, which is visible over here in this picture. These 3 bright stars in the center. and you will see the Milky Way. As the night goes on, you look back to the east and you will see the winter constellations are rising with Taurus and Pleiades, the seven sisters star cluster, and then Orion, Gemini, until the morning comes. In the winter time, we see a different part of the galaxy in the evening time. That means the prominent observation time. This image from Colorado in the Rockies is showing you a ghost town in the foreground, which I have illuminated that building with a little LED inside during the 20-second exposure. Most of you know my photography is mainly based on single exposure photography. Some of them are photo sequence in order to create longer star trails, but more of them are either single exposure or stitched panorama of several single exposure images. I like to challenge myself with single exposure photography. So many interesting methods in that has been practiced by photographers, like Ansel Adams, and is still useful today with modern digital cameras. So in this image, Orion is the prominent constellation in the sky. The winter sky does not have much appearance of the Milky Way, and I will tell you the reason. But instead of the Milky Way, you have plenty of bright stars. Some of the brightest stars in the entire night sky are visible in the winter time of the northern hemisphere, including Sirius. The brightest star in the Earth night sky is this one, Sirius. It is bright because it's only 8 light years away from us. And over here we have Aldebaran. This orange star is one of the giant red giants, or this one, Betelgeuse, on the shoulder of Orion. Betelgeuse is one of those stars that can become a supernova anytime. It's a star at the very end of its life cycle, and it's giant. If it was inside the solar system, the outer surface could be after the orbit of Jupiter. Exposure is very similar in this image, but the Milky Way is not that much popped out because we are looking to the outside of the galaxy. In the summertime, you're looking towards the center or the so-called galactic bulge, while in the wintertime, as well as autumn, you're looking to the suburbs and outside. And since there is no concentration of the mass in the stars and nebulosity, the Milky Way becomes fainter. While in the summer view, you're looking to galactic center and several very rich galactic arms, including the Sagittarius arm, which is very close to where the galactic center is located in the sky between two constellations, Scorpion and Sagittarius. This is the brightest part of the Milky Way. Speaking of the winter sky, and back to that point about stars rising 4 minutes earlier each night, look at this illustration from Starry Night software. January 22nd at 7 p.m., as you can see in the upper part of the screen. And this is for the latitude of around 40 degrees. It's Washington, D.C., so it's mid-latitude. Orion and Gemini are rising at the beginning of the night in January. 1 month before that, at the same time, Orion was much lower on the horizon. You can also measure the change with your hand in the sky. Completely extended arms. This is 10 degrees, your fist. So you can easily calculate this. If you know that the star 4 minutes earlier, so in 1 month, it's about 2 hours. And each hour for the Earth rotation is 15 degrees. This looks like the beginning of the Milky Way season, the popular part of the season, June 21st. It's the summer solstice night. The Milky Way arch is rising right at the beginning of the night. This is 10 p.m. In fact, it is possible to see the same view of the Milky Way right now. This is tomorrow morning at 6:30. So the Milky Way season begins in late January, in fact. We are now comparing the southern hemisphere view and the northern hemisphere. I'm not sure how many people are attending from the southern hemisphere, but I'm pretty sure some of you may want to try photographing the southern sky because some of the elements in the southern sky are so unique and more attractive to most night sky photographers, and I will explain that. But the first difference is not only new constellations you're going to see, including Southern Cross, which is the smallest constellation in the entire sky, but very iconic. The main difference is that some of the iconic constellations visible from the northern hemisphere would be upside down in the southern hemisphere. These two images are from similar latitudes of 30 degrees in two different hemispheres, one in Iran on the right side and one in southern Australia in Tasmania. And Orion is looking about the same time of the year in December, one during the winter time in Iran and the other one during the summertime in Australia. And the view is, of course, upside down. Another difference is that in the southern hemisphere, we can see the galactic center overhead, while in the northern hemisphere, especially mid-latitudes and high latitudes, such as 30, 40, or 50 degrees, the center of the galaxy is closer to the horizon. The further you go down towards the tropics and then southern hemisphere, the center of the galaxy rise higher and higher until when you are just below the equator, you start to see the galaxy overhead. And that's what the Aboriginal Australian, for example, imagine as this giant emu in the sky with the body made of the galactic bulge, and the neck is going all the way to constellation Southern Cross, and where this black nebula known as coal sack is located. This view is only visible in that part of the world. And that's the very reason many photographers would like to capture the night sky in the southern hemisphere. When the center of the galaxy is so high up and it's so bright, it could be easily visible even with the moon in the sky. In comparison, for the southern hemisphere sky between this time, which is their winter time, and our summer time, same month, we are still talking about between February to October, November. That's the Milky Way season. But in the southern hemisphere, it goes to the peak during the winter time, and for us in the northern hemisphere during the summertime. This is the view of the southern hemisphere summertime, which is our winter time. So during, for example, in between November to March, the iconic part of the sky during that time is over the south, which is the upper part of this fisheye view. Both of these images are made with a fisheye lens, a full circular lens which can cover 360 around the horizon. This is just one single shot. You can cover the entire sky when it's properly oriented towards the zenith overhead. This one is it's a panorama, so it has a bit more than the 180 degrees field of view. And when you're using this lens, the perspective is kind of unusual, but it's very useful not only for educational reason, for creative presentation of what you have seen, but also for planetarium purposes. If you have a planetarium locally and you like to contribute, this is the way to go. It's also good for capturing virtual reality images, 360 virtual reality to use with the VR glasses, especially if you do it as a panorama and continue with the foreground, with whatever is located underneath the horizon, all the way to the nadir point. Then it becomes a complete VR. Back to our point, the view during this time of the year for the southern hemisphere is most interesting over south, which is here, including the two galaxies, which are completely invisible in the northern hemisphere. And there are satellite galaxies of the Milky Way, dwarf galaxies, known as the Magellanic Clouds. They are visible to unaided eyes very prominently. And also next to them is the Southern Cross, the Coal-Sag Nebula, and this little nebula visible here is known as Carina. The Southern Hemisphere view of the Milky Way arch. Instead of rising now, you have this view in setting time, which is in October, November evening sky. This one was photographed from Australia, the National Observatory, and also in July, August in the morning time. Or you can see the Milky Way rising in May to July in the evening sky, and that can be in the morning sky in February, April. Speaking of the technique in this image, it's a self-posed panorama. So it's a panorama of about 8 shots. The camera is vertically oriented. On one side is the moon. That's not the sun. The moon is setting at about midnight. So this is again a first quarter moon setting in the Atacama Desert of Chile. And since the altitude is high, when the moon is close to the horizon, the Milky Way becomes completely visible because the moon is getting dimmer and dimmer as it's getting close to the horizon due to the atmospheric absorption of light. When the object is closer to the horizon, there is more absorption of the light, and then the object becomes dimmer. But still, it's bright enough to illuminate the foreground, as you can see on the hills over there. But the sky is not totally vanished. Just above my head is the Large Magellanic Cloud, and on the left is the center of the galaxy rising. When I did a panorama, all the shots were regular, but one of them where I was supposed to be in it was on a self-timer. So I went there, the self-timer was running for 10, 20 seconds, and then the shot started. I had to froze myself to about 10 seconds, and that was it. This is could be familiar to some of you who have seen my other webinars, but I'd like to go through it pretty quickly. The golden numbers of wide-angle night escape photography. They can vary, but this is the average: 15-second exposure, ISO 3200 f2.8. However, you can go to longer exposure if your lens is wide enough. For example, with a 14mm lens, you can go to 20-second, and still stars are pretty pinpoint. You don't see much star tread. The reason we are limited with the exposure, for those of you who are beginners, is the Earth rotation. The Earth rotation is constantly moving the sky above us and creating star treads if the exposure is too long. If you want to freeze that, you have to limit the exposure to these numbers, which I'm listing here. If you don't want to limit yourself to the exposure, then you have to track the stars with a device known as a star tracker. The range could be higher if the field of view of the lens is wider, such as 14 or fisheye 15. The exposure is shorter if the field of view of the lens is smaller, 24mm, 28, 35, your exposure just shrink to lower numbers in order to freeze that Earth rotation. And there's an equation for this, very simple: 300 divided by f. F is your focal length. And that gives you the maximum exposure typically for a medium range resolution camera. For example, 25 to 30 megapixel camera. The higher the resolution, you will see more of that trail because you can zoom in and magnify the rotation. But generally, it's about 300 divided by f, and I will have some samples of the result for you later on in the next few slides. Well, let's go on with the ISO. It could be lower when there is enough light. For example, in this image, I had enough light from aurora illuminating the foreground. So I didn't want to increase my ISO because this ISO, which is not the true sensitivity of the camera, it's a gain. It's how the camera is performing in low light. The sensitivity of the camera is another thing. It's known as quantum efficiency, and it's fixed. But the camera can gain it up or down with the ISO. We don't want to add that gain to a very high number, such as ISO 12,800, because many cameras do not perform noise-free as such high ISO. So your lens, your image becomes noisy. Second, you lose the dynamic range of the camera when you increase the ISO. That means the ability of revealing bright lights and low lights next to each other, the ability of recording good colors, that drops after a certain amount of ISO. And for many cameras, that threshold is about ISO 1600. So I would keep it at 1600 or 800 if there is enough light. But if there is not light, and I like to reveal more of the stars and the foreground, I max it out to the practical ISO for that camera, which is many cases is 6400. The newer cameras are performing less noisy in high ISO. So this could change next year when we talk about these settings with updated sensors and processors. But at the moment, this is the range I recommend for most typical cameras. The aperture depends on the lens. And this is why I usually insist on using a fast lens, because you increase the ISO, the image gets noisy. You increase the exposure, the stars are trailing. But if you have a faster lens, instead of shooting at 2.8, shooting at f2, you are now one stop faster. It's like doubling the exposure in another way. So that's why that's the power of a fast lens in low light photography under stars. You can reveal much more. But when we do not use that, for example, you have a lens, a typical prime lens for night escape photography is 20 millimeter f1.4. Do you really want to use the 1.4 aperture on this lens? What would be the problem of applying that all the time? First, at wide open aperture, many lenses are showing aberrations on the corner, such as coma aberrations. Stars becomes out of focus and also showing bizarre shapes, such as a badminton ball figure. Or it's showing chromatic aberration, stars showing false colors, purple and blue, which is not related to them, but it's the color aberration of the lens. If you stop down the lens, one stop or two stops, these will be much less or completely gone. For those lenses which are starting at 2.8, they're usually free of these aberrations even at wide open aperture. But for very fast lenses, you have to test it if your lens is good enough at 1.4 or f2 or not. And selecting a lens for night escape photography is based on these. Is this lens sharp enough and free of aberration at wide open aperture? Another time that you don't want to use a wide open aperture is when your foreground is too close to you and you like to have the foreground and stars in the same focus. As you open up the aperture, you lose the depth of field. That means you only have a focus on a certain distance. Outside of that, it's out of focus. Closer to it, it's also out of focus. As you stop down the lens, the aperture, you get more and more depth of field. Everything will be in focus, especially with a super wide angle lens. That's not really a topic I can visit completely in this webinar, but I think I have extensively talked about it in webinar number 2, if you have the pack. It's the secrets of the night escape photography. And it's a thing called hyperfocal distance. And it gives you the sense. You can also download this hyperfocal table from web, from online, or it's available in some of the apps I'm going to list as well. And it tells you what would be the closest object in your field of view which has the same focus and the stars. So what would be the closest object you should fit in your field of view in order to have it perfectly sharp? Single exposure blending, it's up to you, and each one of them has its own advantage and disadvantage. With blending, you have to consider a lot of time in post-processing, and from my perspective, you lose some of the originality of the image. For historic reference, for example, you have lost the single raw file, and there are many steps in the processing that is now a part of the digital art. But still, it could be completely real. You know, blending exposures doesn't make your image fake. It's totally real. It's just a taste of the photographer. Or single exposure. I would say if it is possible to capture it in single exposure, why not? Why I have to do blending? If I can do it with single exposure using a fast lens or using very old school techniques. Give you an example on this image, for example. I used my hand with a black glove in front of the lens. The exposure was 10 seconds, but my hand was covering the foreground, the lower part of the lens, for half of that exposure. Just because I didn't want my friend, my colleague during the Aurora photo tours, to be overexposed with the light on his face. And of course, moving. If he was illuminated for more than a few seconds, he would definitely be unsharp. You can do the same hand technique with a city in the foreground or something dark that needs more light. So it's a very simple technique instead of doing blending, and it was used by Ansel Adams. And many of these are available still, but unfortunately, photographers are more and more shifting towards digital techniques in post-processing instead of on-the-field techniques, which are available. So one more thing is about the motion in the sky. And that's completely related. We are talking about the motion of the Earth, of course, but what you see is the stars rising and setting. And if you do a long enough exposure, like the one on the right side, you get the star trails. These are all from one sequence. My camera was vertically oriented, exposure of 10 seconds, f 2.8, and ISO 6400, very close to the golden numbers. I started a time-lapse sequence. Between each shot was only 1 second gap for the camera to restart again. And I continued that time-lapse sequence for about 4 hours. The galaxy is gradually rising. And on the right side, I combine all these images in the sequence in a software called Star Stacks with X at the end. And it created a long exposure image out of that sequence. I do have a webinar about star trails and time-lapse, but just to give you a brief on that, it's a very simple method when you want to combine these on one of these. It's a free software. You can also do it in Photoshop, or you can do just one single shot. But with one single shot, there are many challenges. First, you don't have the time-lapse anymore. Second, if something goes wrong, you lose everything. Third, if the area is too bright, then you can't do that because the foreground or the sky completely vanished. You can't do it in a village or a city because of light pollution. But with a sequence, you have all these possibilities left. And speaking of this image, in fact, if you can see my picture as well on the corner, this is the image on the cover of the Word at Night book. And this is how it's produced from a 4-hour sequence of time-lapse. Now, we want to freeze this Earth rotation in order to get pinpoint stars. And that's the equation we talked about without using a star tracker. Remember, if you're pointing the camera to the poles of the celestial spheres, either the North Celestial Pole near Polaris or in the south near constellation Southern Cross, this motion is slower, so you can expand the exposure. If you're shooting Big Dipper, instead of 20 seconds, you may go to 30 seconds and still it's pinpoint. What I'm referring here is an average for the sky. On a full frame camera, which you get the full view of the lens. So the lens is not, the field of view of the lens is not cropped. Then the normal time of exposure limit is about 20 seconds with a typical wide angle lens. On a crop sensor camera, not sure what percentage of the audience now are using crop sensor, but you have multiple numbers depending on the camera. It could be 1.5, 1.6, could be 2. So it varies. You have to check it out. But on average, it's about 1.5. And this would be the equivalent for you, 10 millimeter, 20 seconds. If you note those telephoto lenses, like 200, we're only limited to 1 or 2 seconds. That's why doing night escape photography on a still tripod with telephoto lenses is difficult. You don't get enough light unless you increase the exposure and stars become trailed, not pinpoint anymore. So with telephoto lenses, we are usually shifting towards deep sky photography using a star tracker instead of a fixed tripod. And speaking of a star tracker, I have a free tutorial available on YouTube on one of these most popular ones, and there is a section about it in other webinars if you're interested to see which star tracker is best for you. Other camera setting, white balance. If you're shooting on RAW, there is no difference in setting the white balance on the camera in post-processing. You have all the information available. But if you want to get the correct image on the camera screen in order to judge what you are capturing, it's between 5,500, the daylight temperature, to 4,000. I don't go lower than 4,000 because it changes the natural color of the night sky too much. Some photographers prefer to shoot the Milky Way and night sky always at very low white balance, like 3,000. Sky becomes romantically blue, the Milky Way is blue, almost everything is blue. This is not real. You know, to me, it's like capturing an elephant and the elephant is red. You know, we don't have a red elephant in natural world unless you're doing it for a fine art reason, for a project, and audience are familiar with your target and message. But unfortunately, since most people have no idea what is the natural color of the Milky Way, these images are very popular on web, where the Milky Way is appearing in all colors of the spectrum. You know, our galaxy is not changing color every night. It's just one color. And depending on what side of the galaxy you're shooting, it goes from pale yellow towards the center to pale blue in very far from the center in those star forming regions in near Orion, for example, or the Southern Cross, and sometimes completely colorless. So we don't have all these diversity of colors or vivid blue Milky Way. This is just simply the result of saturation and white balance shift in post-processing. I recommend to save a small JPEG. Of course, RAW is the essential part, always RAW, even in time-lapse sequences, because you need that information in order to enhance your image in post-processing. And a small JPEG is for a fast preview, and that's recommended too. Focus is the most challenging part of photography of night for many people because you can't really see something to focus. But with today's camera, especially when equipped with a fast lens, as soon as you start the live view and get the focus of the camera almost near infinity, then zoom in, magnify digitally in the live view 3 times, 5 times, and we will see plenty of stars, and go back and forth and focus on them. My method is to start with something bright. It could be a light on the horizon. It doesn't need to be really at infinity. You know, with a wide angle lens, anything at 100 feet or away is completely at infinity. So it could be rather close to you. Or the moon, or a planet, or a bright star. And second step is to look nearby it and look for those fainter stars. They become visible in the live view only when you are in perfect focus. So go back and forth a few times. Then you can tape your lens or use a lens band to fix it for the entire night. Focus peaking is available in most mirrorless cameras nowadays, and it's an option which I recommend. It's not as exact and accurate as manual focusing, but it's very handy and fast. It gives you a color range around the object when it's in focus. Long exposure noise reduction. We have 2 options in the cameras. One is high ISO noise reduction, leave it on as medium level. But long exposure noise reduction is a physical process. The camera takes a second identical exposure with the shutter off. In this shutter off image, which is so-called dark frame, the camera is looking for the noise and remove it from the first image. So you double the amount of process. Instead of one single 20-second, your camera will be busy for another 20 seconds, but gives you a much cleaner image finally. If the camera is not performing too noisy, I would always turn this off because I don't want to lose the battery and time by using this. This option is not useful when you're doing the time-lapse sequence because this stops your camera. So remember those. Interval setting, like in this image that I'm appearing during the AstroMaster class in La Palma every May. We're at this really paradise on Earth, on the edge of this caldera. shooting the one of the best, darkest night sky on the planet in the Canary Islands. And I hope to restart it again. We paused for 2 years for obvious reason, and now we are aiming for May 2022 this year, already almost fully booked. So I hope that we can do it this year. As you can see in this picture, I'm using a device outside of the camera. This is a similar cable release in analog time known as intervalometer. And with this, you can set intervals. You can do a time lapse. Many cameras nowadays have internal intervalometer. You just need to activate it on a certain mode. It can be used with a certain exposure. There is something called interval. Interval is always the exposure plus 1 or 2 seconds for the camera to reload again and record the file. And you can set like 500 shots and you're good to go. Start. Another way of doing this, for example, let's see here. Another way of doing this is just put the camera on burst mode, the sequence shooting. Then click and lock. When you lock the intervalometer, it could be just a simple remote shutter device without any of these programming options. You click and lock it. If the camera is on burst shooting mode, it continues the time lapse until it's out of memory or out of battery. So that's the most simple way of doing the time lapse. But it doesn't work for ramping the exposure during the day or night transition. It doesn't work for very short exposures because the camera buffer can stop you. But let's go over a quick review of lenses too. I always suggest prime, but that means single focal length. But if you want to use a zoom, use a small range zoom, such as 1424, 1530, not 14200. These long range zooms are not made for low light photography. They are much slower than prime lenses. So it's almost impossible to capture a good image of the Milky Way with a long range zoom lens. On full frame, these are the two most popular lenses at the moment, either 21.4 or 1.8, and 14 1.8 is another one. 1424 millimeter 2.8, this lens is probably the most popular lens for time-lapse photography worldwide. And all the other options, with fisheye, you have, as I said, the capability of capturing the entire sky. If the event is something like massive aurora borealis across the sky, that's the lens to use. These are the equivalent for a crop sensor, 1424 and 17200. If I want to travel with only 2 lenses, I would use 1424, 7200. It covers almost everything. And that's the same with most of my National Geographic colleagues. These are the lens field of views. It's just a reference for you for future. One side is crop sensor and the other side is full frame cameras. So you can see with the 14 millimeter, you have almost 100 degrees field of view horizontally. And that's huge. That can include the entire Milky Way arch rising with the 14. With the 15 fisheye, which is not listed here, you have 170 degrees diagonal field of view. When you switch to 35, the field of view is smaller. So now you are focusing only on one constellation, not the entire part of the galaxy. With a 400 millimeter, your field of view now is just 5 degrees. And that is not enough for even one constellation. You're aiming for deep sky objects, for a star cluster, for a galaxy even. Some of the galaxies are completely resolved with 400 millimeter lens, some of the nearby galaxies. One of the most popular targets, of course, besides the darkest sky and Milky Way, is the moon, which you can also capture in city sky, in urban light polluted skies. Let me clarify this. The moon is never that big. This is due to the use of the telephoto lens. And it's a phenomenon known as moon illusion. It's generated by our brain especially when the moon is seen with an object on the foreground. You have this feeling, that you have this perception that the moon is much larger than usual. The moon is the same size overhead or on the horizon, is the same size every night. The size of the moon does not change that much. And this popular term supermoon, I would say it's very misleading. And let me explain why. So from the technical point of view, this is very close to my neighborhood, just basically 100 yards away on the ocean side. The moon is rising over these houses in the North Shore of Boston. I have used a 600 millimeter lens plus 2x teleconverter, so it becomes 1200. And then another crop for presentation in the video and post-processing. The term supermoon is only on average 10-15% larger than a normal moon. You know, for something that is 10-15% larger, you don't call it super, you know. Super moon, people think this is 10 times larger than a usual moon, not 10%. A typical unexperienced stargazer, this is not even noticed. I mean, it's impossible to notice that. But for a frequent stargazer, you will see that it's a bit brighter. You will see that it's a bit larger, just a bit. Now, how do we capture these images? One is a telephoto. So you have to select anything above 400 millimeter. That gives you the best field of view, 400, 600, 800. Maybe you can approach this with a 200 as well, with a bit of cropping. This is the Boston light, again with the 600. I use a manual 600 millimeter lens from 40 years ago. The lens is almost as old as myself. And it's still good enough. It's fine, it's sharp, it's prime lens. And I don't need the autofocus. You know, the difference between that 600 and an autofocus new 600 by the same company is $5,000. And it's not useful to me. I'm not a wildlife photographer. So for night escape photography, we usually use just manual focus. This is with a 200 plus 2x teleconverter from Paris. The moon is setting just before midnight. You can even see a bit of the craters on the moon, which is impressive with using just a telephoto lens. And this one is again in my neighborhood, very vivid color on that evening. And the lens is 135 plus a bit of cropping. So starting with 200, 135, you get to see more details of the moon. But the main challenge is how to align these, the foreground and the background, which is the moon, in one field of view. As you go with higher focal length numbers, the field of view is smaller. With the 600 millimeter, you only have 3 degrees. And if you move just 10 meters, it's totally out of alignment. And nowadays, there are 3 apps that can help you doing this: Photopills, Planet, and TPE. TPE was the original one, first introduced, and then came Photopills by a dedicated group in Spain, and then came Planet by another very dedicated creative person in China. So these are the 3 apps which are doing basically the same. The most popular is probably Photopills. Now we continue with some of the upcoming sky events. In May 15 and 16, depending on where you're located, it's May 16, 4 a.m. UT, which means in North America, this is still May 15 late evening, just before midnight. You have a total lunar eclipse. The entire eclipse is about 3.5 hours. That includes the partial and penumbral, but the total eclipse duration is 1 hour, 25 minutes. It's pretty long. You know, the total lunar eclipses could be as long as 110 minutes and or about that. So this is almost like 2 hours. And this one is long enough that you can do even night escape photography during that. You know, you go on a full moon night at the beginning of the night, there is nothing visible except for just a dozen of stars, completely vanished. And then you see this transition from bright full moon, gradually the Milky Way coming out, sky becomes completely dark. So I would say the best experience for a total lunar eclipse is to be away from light pollution. However, it is completely visible from major cities as well, because you're dealing with a bright object like the moon. But in order to experience that transition, I recommend you to try it in a dark sky place. And it is visible in Americas, Europe, and Africa. So large population on Earth will see this. The penumbra part is where the shadow is not really dark. It's just a gray shade over the moon. You don't see the penumbral eclipse until it's past 50%. You don't see it with naked eye. But as soon as it hits the umbral part, that's where you can very boldly see the part of the moon is gone. So that's the beginning of the partial eclipse. When the moon is in the middle of the Earth's shadow, that's the mid eclipse. And that's when you can try even capturing the Milky Way if you're in darkest sky area. The reason that we see the moon red is the Earth atmosphere. The Earth is refracting some of the sunlight into its own shadow. And when the moon is passing that shadow, is reflecting this light. Only the red part of the spectrum is passing through the Earth's shadow. And that's why we see red moon. The more clouds and dust in the Earth atmosphere, the darker the eclipse will be. Plus, if the moon is passing more towards the center of the shadow. It's showing you what is happening during a typical lunar eclipse. The time is not for this coming eclipse. The total part in the shadow could be few minutes or up to over 100 minutes. For this upcoming eclipse in May, the moon is not crossing the center of the shadow, so the lower part of the moon will be a bit brighter. All the times are GMT or UT, Universal Time. And these are the terms like P1 is the beginning of penumbral, which we don't care about that much, but U1 is the beginning of the partial, and U2 is beginning of the total. So if you look at this map, you will see that the best part of the world is the South America, where all eclipse visible, but also almost all the US and North America in general, Canada, is going to see this eclipse. You may think that the center of that visibility area is the best. It is the best to see the eclipse itself and very high in the sky, but it is not the best to see the eclipse on the horizon with something interesting in the foreground. So from photography point of view, if you like to include a foreground, you're looking at the places where the eclipse starts at moonrise or eclipse ends at moonset. And that would be the west coast of North America, for example, where you can see the eclipse already in red. That red blood moon is visible when the sun is setting. When the sun is gone, a few minutes after the full moon is rising, eclipse already. And that's a very striking view. I will show you a couple of examples. Or if you're in Europe, Africa, you will see the same view when the moon is setting in just before sunrise. For example, in UK or Spain, Portugal, France, all these countries are looking at the time when it's between U2 and U3. This is the view somewhere in West Coast. The eclipse moon is about 8 degrees above when the night begins. So very close to the foreground, and you can do it with a telephoto lens, and as though, you know, the moon will show some details while the foreground is visible too. If the moon is much higher, it's difficult to capture it in a single shot with a telephoto and something in the foreground. Unless you're in a city and surrounded by skyscrapers, then that could be an option, or mountains. This is an example of how it looks when the eclipse moon begins at the beginning of the night in twilight. It's captured about 11 years ago in Iran. If you're somewhere in the central states in the US, for example, and East Coast, now you can see the moon during the total eclipse much higher in the sky, still in the time of evening. And this is the time when the Milky Way is rising too. If you're in a darker sky spot, you can capture the moon and the Milky Way in one shot, which is impossible in any other time other than eclipse. Because of the eclipse, now you can increase the exposure and the moon doesn't get too overexposed. What would be the limit? I will go through that too. Here's an example from 2011. I did one eclipse image with a 15 millimeter fisheye lens in June. So very similar combination, but with the change that the eclipse moon was right in the center of the galaxy. Very unique eclipse, I would say, because not only that, the moon was going exactly in the center of the shadow. So it was the darkest eclipse of our time, the lunar eclipse. And when I tried a telephoto shot, this is a single exposure image. With a single exposure, I was using a modified camera. The nebulosity was visible next to the moon, and the moon had still some details in the view. Some more of it recovered in post-processing. It's not going to be as dark as this one, but still, if you're aiming for some details in the Milky Way and the moon, I would recommend to do an HDR. An HDR is a high dynamic range image made of 3 or more shots. So make different exposures, one for the moon, one in the middle, and one for objects of the Milky Way. And you have to combine them later on in post-processing to have all these range of light in one single image. Then you can reveal the Milky Way and details of the red moon, and even maybe some of these details in the nebulosity in the head of Scorpion. It's known as the Rho Ophiuchi Nebula, next to the brightest star Antares. You need a pretty long exposure, at least like 1 minute, to reveal some of these in detail. If we go back to here, if some of you are more experienced and going to do deep sky photography, a lens between 50 millimeter to 100 gives you enough field of view to include the Rho Ophiuchi Antares star and the eclipse moon in one shot. And then you have to do, of course, as I said, a high dynamic range, HDR, blending of several exposures. The next lunar eclipse is again this year. This one on November 8th, and again visible from most of Americas as well, Pacific, Australia, Asia this time. Let me show you where the moon is passing now towards the northern part of the Earth's shadow. And this is where the visibility is. Africa is not going to see this, as well as most of Europe is going to miss it. But now more of the eastern US and Canada is along that part where you can see the eclipse on the horizon, but in the morning time. And the evening time, Australia and East Asia is going to, or India is going to see it as the moon is rising. It's already eclipsed. And it's not only about total lunar eclipse. You may also be in an area where only the partial eclipse is visible, or only 80% of that. This is an example, 80% lunar eclipse. I have illuminated this apple tree in the foreground during the 8-second exposure. Or this one, the eclipse is ending right before the totality is visible, it's going to set. So I'm going to miss that from that location, but still it's beautiful. Or this one, I was in Boston area and the eclipse to me was visible only a few percent before the moon was setting. And still it was a beautiful sight with a telephoto lens. Look at all those atmospheric refraction on the moon because the moon is so close to the horizon. With a 500 millimeter lens, you have enough of a roundness for foreground and good amount of detail on the moon. This is a 600. A single exposure from my backyard during the total lunar eclipse of January 2019. The exposure is 30 seconds. Obviously, it's on a star tracker because with 600 millimeter, anything more than half a second will be trailed. So in order to capture a 30-second image, you have to follow the stars with the star tracking. Or you can max out your ISO to 6400 and limit the exposure in order to capture it on a single shot. Then you have more noisy image, but it's still doable. If you want to calculate what would be the size of the moon on these images, this is the way to go. And your sensor is 36 millimeter long, a full frame sensor. A crop sensor is about 24 millimeter long. Suggested lenses, 70 to 200, 100 to 400, or it could be fast optics in order to capture that in a single shot. Of course, the Earth rotation is going to change the moon position as well. So it's the same like the stars. In order to freeze that, not getting a blurred moon, use the same 300 divided by f equation. If you're shooting with a high resolution camera, it can be even 200 divided by f in order to have a perfectly sharp image. With a low resolution camera, 10 to 15 megapixel, go to 500 divided by f. So that means with 200, you have 1 or 2 seconds. With 600, you have up to half a second maximum. And it's not only about telephoto lenses. You can also use a wide angle lens, especially if you're in dark sky area. Look at this one with the 14. The moon is tiny, but it shows you the ambient beauty of that total lunar eclipse moment with ocean of stars. Or you can even do a single long exposure on a very low ISO, such as 100, and let it go for long exposure of 1 hour, 2 hours. This was with a film time. I was shooting well via 50 film, and the exposure is 4 hours. It's showing how the moon is shrinking in brightness and to red. And you can do the same with digital cameras today. Instead of a single exposure, I would recommend you a photo sequence like this one. It's a time lapse and then added together to create a long exposure of a moon trail. The major total solar eclipses happening in our time, and another one is coming next year, which we won't talk about it on this webinar, but look at it in the center is 2023. It's a hybrid total and annular eclipse, and the most promising eclipse for those in North America is 2024. It's crossing most of the US, a large part of Canada as well, Mexico as well. And that's an eclipse that many people are looking forward to see. But the one we have this year are two partial. One is only visible from the southern part of Argentina and Chile, a part of Antarctica as well. And it's a partial up to 60%. The other one is in October. More of population on Earth is going to see it. Almost everyone in Europe, with clear skies, and Africa, most of Middle East, Iran. And where would be the most interesting location to see this partial eclipse? It's up to 80, 90%. Either it needs to be in the central part of Siberia, which very few people are going to be there, or it needs to be where the eclipse is starting at sunrise or ending at sunset. So the eclipse is on the horizon. For example, near sunrise, the eclipse is already in development in Iceland, UK, and northern Scandinavia. Near sunset, it's in progress in India, Iran, Middle East, and Central Asia. This would be the view, for example, at sunrise. The eclipse is rising, already eclipse. It's a very dramatic view, I would say. Be careful with safety. If the horizon is not filled with clouds, you definitely need to use a solar filter. On this case, I didn't use a solar filter, and with a digital camera, I use the digital live view, not the physical live view if you're using a DSLR, just to make sure it's not harming my eyes, because the light collecting power of a telephoto lens is quite intense. This is with a 600 millimeter, a seagull is passing by. When there are clouds, there are lots of beauty for even a partial solar eclipse. Otherwise, a partial solar eclipse could be very boring because you don't see the corona of the sun. There's nothing happening. The light around you doesn't change much. But with a bit of clouds, everything becomes very dynamic. Under trees, you will see these hundreds of pictures of the crescent sun forming, because each hole between the tree branches and leaves is creating a pinhole camera and creating one of these images, or using a solar filter. Also looking around with people who are looking at the partial eclipse, safety, A typical professional setup for eclipses. Fred Spenak, my colleague at the World at Night, who is also a very well-known NASA retired astronomer, still in charge of the NASA eclipse bulletins, have seen almost all the eclipses in the past few decades. Moon and planets conjunctions. Moon and Venus is the most iconic view. And every month from now until August, we're going to have one Moon and Venus pairing in the morning sky. The most interesting ones are listed here. April 27th, for example, the Moon and Venus will be accompanied by Jupiter. Jupiter is another bright planet in the sky. May 26th, May 27th, there is a Moon and Venus conjunction where in Asia it becomes occultation. That means Venus will be hidden behind the moon for some time. In June 26, Pleiades and other planets are around this conjunction, so it's very unique. And on August 25, it's in twilight and close to the horizon. The moon is very thin. December 24th, a couple of months, Venus is no longer visible because Venus is in conjunction with the sun. That means it's completely invisible. So it's going from the morning sky back to the evening sky. When it comes back to the evening sky in December, it forms another conjunction with the moon on December 24th. And then in January 2023 and continues, it's all in the evening sky. That's why Venus is sometimes called the morning star and sometimes called the evening star. This is a conjunction with Venus, Moon, and Mercury. Mercury is the one between the two. And instead of a single shot, I did a long photo sequence, and this is the result. Just to give you an idea of all the creative ways of capturing these celestial phenomena. This is Venus and Jupiter next to the Milky Way in one single telephoto shot, another kind of conjunction. Now let's go through some of the other interesting planetary alignments. The good news is we have plenty of these planetary alignments. This is spring and all over to June and July. The bad news is all of them are in the morning sky. So you have to wake up pretty early to see these. March 24 to April 5th, Venus, Mars, and Saturn. And Moon joins them on March 27 and 8th. This is also interesting for those of you with the telescope. Saturn and Mars on April 4th are half a degree away, half a degree, almost like emerging in the night sky to the naked eye. If you use a telescope, both of them are visible in the same field of view. Mars would be a little disk, red disk, and Saturn with its ring next to it. Or if you have a very long telephoto lens, it's not really an easy target to reveal Saturn ring with any telephoto lens. It needs plenty of magnification. But also with a wide angle lens, this combination of all these planets in the morning sky, it's quite unique and interesting. I wouldn't say it's a rare phenomena because we have plenty of planetary alignments, but each one of them has its own beauty. After March 27, 28, they're going to scatter in the sky and getting higher and higher. April 30 and May 1st, two brightest planets in the Earth night sky are getting together, close together. And that's a very iconic phenomenon. Some historians refer it to the Star of Bethlehem. The origin of the Star of Bethlehem could be very close conjunction of Venus and Jupiter, and it happens every few years, but every now and then it becomes very close, almost merging together. This is one of those closer ones, although not a super rare event, half a degree. So at the first glance, you think it's just one object there. Then you look for a couple of seconds and you see that obviously there are two beacons in the celestial sphere at that night. It's very interesting to look at it with a telescope as well, because then you can see the moons of Jupiter, for example, next to it. This was a similar event in 2012. I captured from Lapland with aurora activity. This is another Venus and Jupiter event captured over Boston. So you can see the city is dominating the view. And it was interesting to me because the message was how the celestial beauty is completely hidden from city areas. And people were walking next to me until a couple stood there and asked me, "Are you capturing Boston?" I said, "No, I'm capturing those two planets." Then they realized there's something visible beyond our city, beyond everything which is occupying the natural world for us. And then they were just talking about that for several minutes. They were so amazed. Have a closer look. Venus is much brighter than Jupiter. Planetary alignment. Now you're looking at 4 planets here. This is an image from 2002. I was in the World Heritage Site in southern Iran, where these ancient Persian monuments are located. And I was illuminating the monument, was there myself for half of the exposure. That's why when I left, I became like a ghost in the shot. The crescent moon and 4 planets on this single exposure on film. Jupiter is the upper part, Mercury is there too. And this is the view. We're going to have a similar one in the morning sky in late June with 5 planets. They're much more scattered, so you need a pretty wide angle lens in order to capture that. Even Uranus is there too. However, you need a very pristine dark sky to record that or to see it visually. You know, Uranus is not a telescopic planet. It's visible to naked eye if the sky is very dark. The moon will pass near this area and between each one of these on those dates I've mentioned, including Moon and Venus conjunction on June 26. One more, Saturn opposition on August 14 and Jupiter opposition. What does it mean? That means the whole night these 2 planets will be visible. During the opposition, the planet will rise at sunset and sets at sunrise. The whole night is there. Plus, it's at its brightest, closest to the Earth. So that's where these 2 planets are brightest this time, either, within a few weeks from this exact opposition time, you will see them very brightly in the sky. Saturn is never really bright in the night sky because it's too far away, but Jupiter could be quite prominent in our night sky. Mars opposition is interesting because Mars, for most of the time, it's not a bright planet. But when it becomes in opposition, it's closest to the Earth, and it could be even brighter than Jupiter slightly, or almost as bright. And with that red color, it becomes very eye-catching and photogenic as well. And it's going to be on December 8th. Not only it happens this year, but it's very interesting location in the sky too. Mars is next to Pleiades star cluster during that time, in Taurus, the bull. But something more exciting is happening for people in East Asia. Moon is going to hide Mars on July 21st in an occultation. So the conjunction is so close that the moon is covering Mars for some time. That's called occultation. And again, on December 8th, the same night that Mars is approaching closest distance to the Earth, it's going to be an occultation visible in US and Canada and Western Europe. So that's quite something because Mars is at its brightest time and moon, full moon, is going to occult that. And it's visible in such a huge area. Not everywhere in these 2 continents. So let's go with Mercury. Most of the time, Mercury is not visible. Why? Because it's so close to the sun. But during sometimes it's called elongations, we have very good view of Mercury on the horizon. It's always within twilight. You know, Mercury is never too far from the sun to see it in a totally dark sky. But during the elongation, it is possible to see that the beginning of the darkness with some stars. And these are the most interesting times I found out in my research. So some of you may wonder when would be the good time this year to see aurora. As you may know, I have 2 annual photo tours for aurora in March and September. And the next open aurora photo tour is in September 2022. Why we go for aurora chasing in March and September mainly? The sun eruption can happen anytime. These massive eruptions are responsible for aurora on our planet because they eject so many solar wind that when the wind is coming to the Earth, if it is directed to our planet, it's going to make a geomagnetic storm in our planet and create all these beautiful lights. But during the equinoxes, that means March, April, September, October, the Earth is receiving more of these particles due to just the orientation of the magnetic fields. Nothing happening extra in the sun. It's just about the orientation of the Earth magnetic field and the sun during the equinoxes that increase the chance of seeing good aurora. The aurora borealis is directly related to the solar activity. The solar activity is in an 11-year cycle, and we are now heading towards the maximum, the solar max, the next one. The appearance of solar activity is the sunspots. The more sunspots we have, the more active the sun is and aurora becomes. So if we count the sunspots, we can tell when the solar max is happening. And at the moment, it seems to be 2024 because the sunspots are increasing more than predicted models. So it's not 2025, but 2024. From now until 2024, we have stronger auroras, and it continues for another 2 years after that. So this is truly the aurora time. Aurora from space, aurora from the ground and with a fisheye. I do have a webinar on aurora on my page, also a free lecture about aurora photography and viewing, which is available on my links, babaktafreshi.com/workshop. And this is a very interesting website, has been around for many years now, giving you up-to-date information about aurora activity and any other celestial and atmospheric phenomena. It can even you can even register for text alert to receive when its aurora is active. This is the zodiacal light. It's not a transient phenomenon, it's always there, sunlight reflection from dust in the solar system plane. And you also need to see it near the equinoxes in mid-latitudes. In the tropical areas, it's always visible in the darkest sky place. As soon as you are facing some light pollution, this is gone. Some of these very elegant pieces of the night sky completely vanished by the light pollution. And meteor showers. I'm sure many of you signed up for this webinar to learn about these two exciting meteor showers which are going to happen this year. The previous image was from Yosemite. It's a composite. It's not a single exposure, composite of 15 different exposures in order to show what was the activity in 20 minutes near Pleiades rising above El Capitan, and over there is Half Dome. Yosemite National Park of California, the moon is setting on the opposite direction during the August Perseid meteor shower. This is also during the Perseid in Armenia, a World Heritage Site in Armenia. Let's go through some of these meteor showers this year. So first one is the Eta Aquarids. This is a southern meteor shower. The constellation is visible from northern hemisphere too, but it's best visible from the southern hemisphere. You can see plenty of meteors in northern hemisphere too, but it's best for the equatorial area, tropics, and the southern hemisphere. This one, it's made by a comet which was broken in many fragments. And because of that fragmentation, they're now a very fresh stream of particles, which is crossing the Earth orbit. A meteor shower, nobody knows how it's going to behave, but it's expected to be at least 50 meteors per hour during the peak. The best meteor showers of the year are usually Geminids and Perseids with 100 to 200 meteors per hour. So this is almost near one of the good ones. And it could be several times more. Nobody knows at the moment. It's impossible to predict it more accurately. But what we know is that the particles are coming to the Earth's atmosphere at a very low speed that generally create fainter meteors, but also more interesting to capture them because they're going very slow in the sky, and that allow the camera to capture more light. So photographically, maybe it's more interesting, but it's not going to create many bright fireballs. But as I said, it's impossible to predict. Let's plan for it. It's going to be on 5 UT, no moon. This is a perfect time for North America, as well as Central. In the South America, this constellation is a bit too close to the horizon. It's also a very good time for West Europe, just before morning light. Yeah, it's no moonlight, so it's perfect. Perseids is the most popular meteor shower to watch because it's in perfect time of the year. Nights are warm and relaxing, and it's very active always. But, you know, as you can see here, this year, unfortunately, is at the same time with almost full moon, 2 nights after full moon. So most of the fainter meteors will be invisible. So Perseids is not on its best year this year, but still it's one of the best to watch. Orionids, this meteor shower is made from debris of Halley's Comet, but it's not one of those most intense. It's up to about 20 meteor per hour at maximum, at the peak. So you don't expect to see more than 1 meteor every few minutes or so. Leonids, it's usually not active, but every now and then we pass through an old debris of this comet, which is surprising. And this year, there are several experts who predicted that not on the exact usual peak time of November 17, but on the 19th, it's going to be possibly a meteor storm, up to 200 meteor or even more per hour. That means every minute you're going to see 2, 3, 5 meteors. Maybe every few seconds you will see 1 meteor. And it's usually has a very sharp peak. And this peak is again visible in the North America as well. Geminids is usually the best meteor shower of the year. But many of you may never try that because it's in a cold December night and maybe cloudy, but it's really the best meteor shower usually on average. Unfortunately, this is during almost full moon. So this year, Geminids and Perseids are not going to be the prime ones, but these less familiar meteor showers like Leonids and Herculids are going to be the main show. Still, I do recommend you to try for Geminids because it has plenty of bright meteors, and with a bright moon, the foreground will be nicely illuminated. If you have a camera that can capture real-time videos of the night sky, that would be also an option to try. On January 3rd, we have this meteor shower Quadrantids. It's only good if you're in the right longitude. Otherwise, you're going to miss it. And this is in next year. You may capture fireballs like this during the meteor shower. Every few years, we have a bright comet. There is no predicted bright comet for 2022. We just had one in December and November. We had one of these usual bright comets, which created a very long tail, but in the southern hemisphere sky. This is comet Neowise in July 2020, which was visible perfectly in the northern hemisphere. Not like this to the naked eye. This is with the telephoto lens, but it's still visible to unaided eyes. And the last part of the talk is about some unexpected phenomena nobody can predict, and it could be related to the rockets. So these are a part of UFOs. You know, most people don't realize they're related to natural or man-made phenomenon, and we call them UFO first. To me, this was a UFO when I captured that. I had no idea what is going on back in 2007. And then I realized these are not that rare, you know, anywhere near the rocket launch areas or above the right when the launch is above that part of the board, you may see one of these, and it's exhaust of the extra fuel going to space and then reflecting sunlight, or the ignited gas in the Earth atmosphere as the rocket is launching to the space, and it creates some bizarre shapes. These are some examples from different years, different parts of the world, and they all puzzled the locals. Look at that one in Norway, 2009. Imagine you're a villager in northern Norway, and all of a sudden see that. It looks like a wormhole in the sky, but it was just like simply related to a malfunction rocket launch. Some more examples. And these are the resources I would recommend you to have a look for celestial phenomena. Sky and Telescope is the most prestige astronomy magazine worldwide, based in Cambridge, Massachusetts, and been running for more than 75 years now. The website is excellent source for stargazers. Spaceweather.com I just mentioned. Twanite.org is my own project, The World at Night, which I'm doing with a group of 40 other photographers with 25 countries. I started this project in 2007, and the book, The World at Night, is a representation of the activity we're doing. On twanite.org, you will find the world's most diverse collection of night escape photography in order to see how each one of these phenomena look like in real photos through the years. This is the best source you can find. heavensashabove.com is a place to find where and when to see satellites in the sky, bright satellites such as International Space Station. These are some of the NASA websites I used for this resource. One is the Eclipse part, the other one is the NASA Visualization Studio. And these are some of my own resources. On YouTube, you can find me where I have a number of videos and tutorials. Also on workshop page, you will see more of my activity. On the VR, I do recommend you to have a look in order to see from each season and each hemisphere, how do you see the night sky in real photos? So you embrace yourself by the night sky around in these VR photos, which are made from 360 panoramas. And on that page, Darkest Sky, you can see where to look for the darkest skies near your area. These are the apps I talked about, the Stellarium, Starry Night. Some of them are available for mobile devices like the Sky Portal, Sky Safari, and some are free, the photography apps. And this is my colleague's website, which has plenty of tutorials on how to use Planet. Do we have questions on the chat left?
Yes.
Answered?
Yes, we do. We have two from Esther at 2:21. She asked, what can and cannot be seen if you were right at the equator?
Equator is the best place on the planet to see the night sky because you see both the northern hemisphere and the southern hemisphere view. So equator is the place you can see the center of the galaxy rising very high. You can see the Magellanic Cloud. You can see the zodiacal light very well. The only missing thing is that you don't see Polaris high up in the sky. So if you're going to use a tracking device, it's very tricky because you don't have any pole, either south or north are not visible in order to align your star tracker.
Esther also asked the Saturn opposition. Can you capture this within the Perseid meteor shower?
Yes, I mean, Saturn and Jupiter oppositions are nothing very photogenic to capture because it's just a planet becomes a bit brighter than normal. But yes, that's during the time of the Perseid meteor shower. So on that night when you're out, you have plenty of options. You will have Milky Way at some of its one of its best time to see. You will have some of the winter constellations rising in the morning when the Perseid is peaking up. It's usually in the morning times. Most of these meteor showers are reaching the peak in the morning after midnight. And when that happens in mid-August, you're going to see Orion rising, for example. So it would be a night with plenty of activities, and Saturn opposition is one of them.
Tanya asked, when you were talking about night sky photography and golden numbers, what if my lens is 4.5 or 5.6?
Try a new lens. Well, yeah, it is possible to increase the ISO. So you can do higher ISO 12,800, and of course you expect to see more noise. But if you're shooting in a very cold night, so that's the thing, you know, if the ambient temperature is very low, the noise is less on the camera. The higher the ambient temperature around you, the camera becomes noisier. So if you want to shoot with a very high ISO, choose a cold night. The other approach is to do longer exposure. So instead of getting limited with pinpoint stars, make a bit longer exposure. Stars will be trailed a bit, but still you are managed to reveal more of the night sky. So another way is to invest on a manual lens. You don't need to invest on the most expensive lenses, just a manual third-party lens made for your camera by companies such as Samyang or Rokinon or many others, Venus Optics. All these are producing manual lenses which are pretty sharp in wide open aperture, and use a manual prime lens at 2.8 or faster.
Tarek asks, before getting a star tracker, what are some checks one should do on their night photography skills?
Yes, definitely you have to try around all the spectrum of the golden numbers of nightscape photography, you know, trying all these hyperlapse things, hyper distance, which we talked about, the depth of field, the exposures, various apertures. So I would say you give it at least 10, 12 sessions of outdoor night escape photography, then you go with Star Tracker. Star Tracker is the second step when you're a bit familiar with everything and you're comfortable using your camera at night. That's when you're comfortable to add a device. And use a Star Tracker which is the most simple, most compact and light, such as Polari by Wixon, which is my favorite one I usually use. It's a pocket size and it's very easy to assemble.
And then Tim was wondering, what magnitude comet can you capture with the telephoto lens?
So let me, for the rest of the audience might not be familiar with the magnitude, is the scale of star brightness, any object in the night sky. We have magnitude, 0 magnitudes for very bright objects, such as sun is -26. So each one magnitude is 2.5 times in brightness. Like 5 magnitude difference is 100 times in brightness. The brightest star in the night sky, Sirius, is -1. Vega is 0. Polaris is 2. The faintest star you can see with your own unaided eyes is 6. A typical night escape photo of 20 seconds with a fast lens gives you the magnitude of 8 or 9. With a telephoto, you can reach 10, 11. On long exposure on a Star Tracker, you can reach 14, 15.
Stefan would like to know, how do you film meteors, Perseids, Geminids, equipment, exposure? He's wondering.
I think one of the webinars in my set is about meteor photography. Am I right? Yeah, I think so. Yes. Yes. So one of the 9 webinars in the set I have is about meteors, but the videos of the meteor is pretty new. So just to give you a brief, you need to have a camera which has high sensitivity, real sensitivity, not just the ISO. That is a low light camera. So you can use it at ISO 25,000 to 50,000, in that crazy range. And definitely you need a lens which is prime at 1.4 or better, 1.2, 1.4, equipped with that high sensitivity camera. Then you start to see things in the night sky in real-time videos. You can see aurora, like this image behind me. You can see Milky Way even. With a few of the cameras, it's possible to record Milky Way in real time without much noise at these very high ISOs. Or you can capture meteors. So combination of these 3. Some of the cameras allow you to bring down the shutter speed, that means longer than usual videos. Usual videos is 1 to 30 of a second or 1 to 25. If the camera let you to go to 1 to 8, 1 to 4, then it's kind of frame dragging. It's not real because you need 25 frames per second in order to create a video. So you can't do exposure of 1 to 4 of a second. But it's copying the frames. It's basically a fast time lapse. Then you can see much more of the night sky. Sony and Canon, both of them allow you to go to frame dragging to 1 to 8 or 1 to 4. I use a Sigma FPL camera for videos of the night sky. This is a very compact full frame camera, and Sigma Art has all these very fast lenses. So I equip these two together and create real-time videos of the night sky. Other popular cameras for this purpose is Nikon Z6, Canon R6, and Sony A7S is probably the most popular low-light camera.
Eric would like to know, is it difficult to capture a 4% crescent moon right before sunrise? What settings should I use for capturing it with a 400 or 500 millimeter lens?
It is not difficult. I mean, it's a very thin moon, very thin and very close to the horizon. So you need a very good transparency on the horizon. So a clear day, no cloud on the horizon, somewhere outside of the smoke of the city, preferably. And the setting is with the 400, you are limited to maximum of 1 second. So it's definitely less than 1 second. Otherwise, the moon won't be sharp. It's moving due to the Earth rotation. And most important, I would say, is the stability of the tripod when you're shooting at 400 on half a second, 1 second. If you're using a DSLR camera, definitely shoot with mirror lock up, because when the mirror is going up, it's going to shake the camera. If you're using a mirrorless, you don't worry about that. There is no mirror to go up. And use definitely remote or self-timer. Do not touch the camera at the time of shooting. That's another reason to using a remote. So probably a 4 or 5.6 or whatever is provided on your lens, 1 second. And ISO, it depends on how much light is in the sky. It varies every moment, every minute during the twilight. So it's going to change.
We have two more questions. The first is from James. What astro modification, Spencer's camera, in other words, do you recommend, HA or full spectrum?
Yes, astro modification is when your camera is going to be changed in order to capture more of the nebulosity in the sky. Any camera can capture this nebulosity. When you remove one layer in front of the sensor, it's known as IR cut filter. When you remove this filter, your camera receives more of the red end of the spectrum. They're cutting the red end. Unfortunately, they're cutting it right where the astronomy is important. It's known as H alpha region, where all these red nebulosity in the sky are shining. So if a photographer wants to capture more of these red nebulosity, you have to remove that filter either completely or replace it with another one which cuts after H alpha. That is known as astro modified. If you completely remove it, the camera becomes full spectrum. I do not recommend full spectrum for a beginner or for night-scape photographer, because you still want to cut most of the infrared. You're not going to do infrared photography. I do recommend the astro modified only if you're experienced. Do not get involved with astro modified camera when you're a beginner, because white balance would be an issue. And also the camera is no longer perfectly workable in daytime. The colors are bizarre and you don't know what you're shooting. So this is the second step.
Mary would like to know, what is your favorite tripod for stability?
Any of these popular brands by Manfrotto or Gizzo. Most of my tripods have been Gizzo, not only because of stability, because they're long lasting. You know, I invest on something expensive once and it's good for 20 years. That's the way I like to go. And I sometimes buy used tripods. Tripods are not like lenses, which you are not comfortable buying used. Buy a used tripod, it's not a problem, but buy a good one. If I want to spend 500 instead of a brand new, I buy a used Gitzo. Speaking of the world at night, this is not a photo guidebook, but I have plenty of information inside for those who are interested in finding darker skies or some techniques in the night sky photography. However, this is not your guide to astrophotography. There are some other books by my colleagues, like by Mike Shaw, which goes through all the details of astrophotography. This is a coffee table book about the beauties of the night sky with plenty of information on astronomy aspects of that and the stories behind the world at night photography.
Yeah, what tool would you use to stitch images together?
The software I use is PTGUI, PTGUI. It's a French software, but there are other free equivalent for that. For PTGUI, you can use Auto Panel, for example. You can simply use Photoshop under the option Photo Merge, which is available both in Adobe Camera Raw and in Lightroom. However, with PTGUI, or the equivalent freeware called Huggin, Hugin, you have control points. You can tell the software this star in this image is exactly this in the neighboring shot. So a stitch would be much more accurate.
Yeah, two more. One from Sajal. Could you recommend good fast lenses which would not have aberrations and other issues when capturing the night sky?
Yes, I use primarily Sigma Art lenses, and they're pretty good at wide open aperture, like 24, 1.4, 14, 1.8, maybe usable at f2. Some of the telephoto lenses are amazing in this range, and other companies are producing that as well, but the Sigma ones are cheaper.
Hi, thanks, Babak. It was very useful. I'm in the UK and I'm starting this fascinating journey. Which are the areas you would recommend? Where could I start looking for Milky Way in the nearby?
Where are you based?
I'm in London, but happy to travel 2 hours, 3 hours.
So in London, probably the best place you can go is somewhere in Wales, and there are darkest sky places there. If you go to that page I gave as a resource at the end, babaktafreshi.com/darkest sky, there is a map you can download, add it to the Google Earth, and it becomes a layer on top of the Google Earth. It shows you the darkest sky areas. It shows you colors of different areas, light polluted, and look for the dark areas, and that's it. However, if you want to be completely certain that the place is dark, look for go to the darkestsky.org, which is also on that page I gave you. And they have a map of the designated darkest sky parks around the world. And in these parks, they have to follow the rules. All the lights should be sky friendly. Within a certain distance, everyone should switch off at certain time. And that guarantees you it's going to be dark. And a couple of them are in Wales. Yes. Another place you can go from UK is with a direct flight is Canary Islands, where I do my annual masterclass in May. And if you go to any of the two, Tenerife or La Palma, they have darker skies.